Hi, fourth grade. So today's math lesson video, it's gonna be on comparing a pair of fractions. So I actually went ahead before I started this video and I wrote down the objective. I will hold it up for you. Okay. Notice the date right here, March 25th. Objective: students will use models to compare a pair of fractions. Okay. Today we're going to use models to compare. Tomorrow I'm going to show you a different method. So between today's lesson and tomorrow's lesson, you can decide which method you prefer to compare. And so remember, when you compare a pair of fractions, it's less than, greater than, equal to. Okay. So I'm going to start with example 1. Okay. Give me a moment. Hopefully you're writing this down in your notebook or some sheet of paper that you have, okay? Example 1. Okay, let me look on my notes for a moment. Okay, so I'm gonna write down the fraction 5/12 and 9/8, okay? 5/12 and 9/8. Yeah, okay. So, give me a moment. Yeah, 5/12. All right. So example 1, 5/12 and 9/8. Okay. Notice first thing that the denominators, remember the bottom number of the fractions, are different. So you might think like, how do I know? Okay, or how am I supposed to know? How am I supposed to figure this out? Okay. And again, we're using models. Okay. So first thing is I'm going to create two sort of rectangles. Okay. And the rectangles, they have to be the same length, okay, in order for this to work. So give me a moment. Okay. All right, so before I continue, okay, we have this rectangle, okay, this is going to represent the fraction 5/12, okay, so just to make sure, I'm going to count how many spaces or how many parts are in this rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? Again, this one's going to represent 5/12. Notice the second rectangle, it's about the same length. It's a little off by like a little bit of a millimeter or whatever, but it's essentially the same length. This rectangle is going to represent the fraction of 9/8. So let's make sure that they're, hold on a second. 9/10. Okay, let me make that correction right now. Hold on. 9/10. 1, 2, 3, 4, 5, 6, 7, 8. Let me redo this. Oh, Miss Quigley is a little out of it right now. Sorry, boys and girls. Let's see. 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, that's better. Okay, so 9/10. Okay, this rectangle represents that 9/10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now, okay, give me a moment. Okay, notice now, okay, I labeled this fraction model 5/12. And I've shaded in 5 parts of those 12. Okay, 1, 2, 3, 4, 5. Okay, now I'm going to take the fraction 9/10 and correspondingly shade in 9 parts. Okay, and I'll label it. Okay, so here you see 9/10, and in this fraction model, I've shaded in 9 of those 10 parts, okay? So if I rewrite these fractions, 5/12 and 9/10 down here with a circle to put in either less than, greater than, or equal to, okay? I'm gonna give you a minute to think about it, but which fraction is greater? Okay, is this fraction greater, 5/12, or is this fraction greater, 9/10? So if you notice, obviously out of a whole, okay, so this whole, okay, only 5 parts are shaded in, but visually you can see out of the whole, 9/10 is greater. So 9/10 is a greater fraction because there's more parts to that whole that are shaded in. So this is what it's gonna look like. Okay. Since 9/10 is greater, okay, but the fractions are written like this, 5/12 is blank to 9/10, then we have to acknowledge that 5/12 is actually smaller. So 5/12 is less than 9/10. Okay, so some of you might be a little confused right now, so let me clarify it, because I did say that 9/10 is greater, and then you're thinking, well, why did you put the less than sign? Okay, if this were reversed, okay, and 9/10 was first in this like comparison equation, comparison equation, then you would write it differently. You would write 9/10 is greater than 5/12. So I'm going to show you what that would look like. Okay, so again, same fractions, different order. 9/10 is greater than 5/12. But again, the original problem gave us these. Okay, so because 5/12 came first, we know that 5/12 is a smaller fraction. Okay, then you write less than. Okay, so that's example 1. Okay, I'm gonna do example 2. Okay, so make sure that you have some space in your notebook or wherever you are writing. Okay, let's see, next one. Okay, we're gonna do, look at my notes. We'll do 5/8 and 1/2, okay? So example 2, 5/8 is greater than, less than, or equal to 1/2, okay? I'm gonna show you what that looks like. Okay, we have here example 2, 5/8 greater than, less than, or equal to 1/2, okay? So again, step 1, you have to draw 2 models. I always use the models of rectangles, and I stack them above each other, like right up and down, or above and below each other rather, because it's easy to compare. If you draw the rectangle side to side, it's harder to see visually if they're like less than, greater, or equal to. Okay, so give me a moment. Okay, so here you can see, okay, we have this fraction model. Okay, there are 8 parts to represent 5/8. 1, 2, 3, 4, 5, 6, 7, 8. It's a whole, but the whole is cut up into 8 parts because the denominator again has 8. Over here we have 1/2, and the bottom rectangle represents a half. We have a rectangle, we just cut it in half, okay? 2 pieces, 1, 2. Okay, so now I'm gonna shade 5 of the 8ths in the first one, and I'm gonna shade 1 of the half of the second one, okay? Okay, so see here, okay, 5/8 shaded, 1/2 shaded, okay? Now, if you look at it, you can see which fraction is bigger, which fraction has more value to it is 5/8, okay? So looking at our comparison, okay, equation, 5/8 is greater than, less than, or equal to 1/2. Looking at your models, okay, you should be able to determine that 5/8 is in fact greater, not by much, but it is greater than 1/2, okay? So it would look like that, okay? 5/8 is greater than 1/2, okay? I'm gonna do one more example for you, okay? And then I will let you do your work. So this would be example 3. Okay, let me look at my notes here. Let's see. Did 5 I'm trying to find a good one for you guys. Oh, here we go. 7/12 and 3/4, okay? 7/12 and 3/4, okay? Here we go, okay? 7/12 and 3/4 is greater than, less than, or equal to 3/4, okay? So again, step 1, we draw 2 rectangles stacked above and below each other, okay? And then we've got to shade in the parts to figure it out. So let me do that for you real quick. Okay, so here are my models, okay? So this first rectangle, okay, is gonna represent the fraction 7/12, okay? And this rectangle fraction is gonna represent the model of 3/4. And again, I didn't mention this in the example 2, but just a reminder when you're doing this method of comparing fractions, it's very important that your models are the same length, okay? If they're a little off, that's fine, but like if they're significantly longer or shorter than your other model, it's not gonna work, okay? So notice mine start at the same spot, okay, and they end at the same spot, okay? So now I'm gonna shade in, okay, 7 of these parts, okay? I'm only gonna shade in 7 because it's 7/12. There's 12 total parts, but I'm only shading in 7. And then this one, I'm only shading in 3 because there's 3 parts shaded out of 4 total, okay? And then we can compare. Okay, so here's my work, okay? Actually, hold on a second, I forgot to do one thing. Okay, so I labeled my fractions, okay? So you see here, 7/12, 7 parts are shaded. Okay, here, 3/4, 3 parts are shaded. Okay, you see that the 3/4 fraction is more. There's more parts. I shouldn't say more parts. There's more value shaded. Okay, you can clearly see that. Okay, which means that the 7/12 is actually a less amount. So the fraction is less. Okay, so looking at this, okay, comparison equation, I can say that 3/12 is less than 3/4. Okay, 7/12 is less than 3/4. Okay, see that? So that's your example. So I think my biggest takeaway for you guys right now is something I just kind of thought of. Just because that 7/12 looks bigger, because 7 we think is bigger than 3, okay, we think 12, okay, is bigger than 4, okay, when it comes to fractions, that's not necessarily the case, okay? So don't think like whole numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, these are fractions. So fractions are a very different beast, okay, than whole numbers. So again, this method is just using models, okay, to compare fractions less than, greater than, equal to. Okay, tomorrow we're going to focus still on comparing fractions, but we're going to use a different method. So today, if you're like, I don't like this method, it's not for me, okay, just try your best, okay, and tomorrow I'm going to teach you a different method. I will hold up this one more time so you can see all the examples. Okay, so we have example 1, example 2, okay, and example 3, okay, using less than, greater than, or equal to. And actually, why don't I do one more thing for you guys, because I know I'm going to get questions about it. So less than, okay, is one direction. Okay, greater, the other direction. Okay, and then equal. I'm sure all of you remember what the equal sign looks like. Okay, so one little tidbit right here, okay, for those of you that forgot, okay, less than, okay, it's pointing in that direction. Greater than, I always say, is like a crooked 7, and the equal sign, hopefully you guys know what the equal sign looks like, okay? So less than, pointing to the left, greater than, pointing to the right, or I always say a crooked 7, and then equal is just, you know, 2 lines that are parallel to each other. I hope that this was helpful to you. Remember that you can like pause, rewind, replay all of this, fast forward if you need to. Feel free to send me any questions that you have. All right, bye 4th grade, talk to you soon.